Hey guys, so I heard a lot of feedback from you that you were kind of wanting to get back to having the lessons taught by me and kind of doing a mix of this and a little bit of Khan Academy. So that's what we're going to do moving forward. I understand with geometry it's a lot different than other math, and it can be hard to learn through somewhere just like Khan Academy. So we're going to be kind of mixing things up a little bit as we go and using Khan Academy, using videos of me teaching lessons, and I'll be finding some other resources to throw in as well. So for today's lesson, what we're going to be doing is lesson 8.5 out of your book, which is on angles of elevation and angles of depression. But before I get started, I want to do just a quick review of what you guys did in the last couple of assignments on Khan Academy. And so when we're given a right triangle, so we have the little square there to show us that it's a right triangle, we can use the trigonometric ratios sine, cosine, and tangent just like you guys were doing. So in the Khan Academy videos, I don't remember if he talks about this or not, but there's actually a little thing that you can use to help you remember which of the trig ratios you should use when you're trying to find a missing angle or a missing side. And again, we know that the trig ratios are sine, cosine, and tangent. So in order to remember, what we're going to do is we know that the sine of an angle is equal to the opposite side over the hypotenuse. The cosine of an angle is equal to the adjacent side over the hypotenuse, and the tangent of an angle is equal to the opposite side over the adjacent side. So those are our three trig ratios, sine, cosine, and tangent. And the way that we can remember which one to use is through what's called SOHCAHTOA. And we write it out just like that, SOHCAHTOA. So here for sine is the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse. And TOA, the tangent, is the opposite over the adjacent. And so to determine which side is which between the opposite, the adjacent, and the hypotenuse, it just depends on what information you are given. So if we're working, let's say we're working with angle A right here. We have three angles, A, B, and C, and we have three sides, AB, BC, and AC. So if we're working with angle A and we have the three different sides here, the way this works, the hypotenuse is always the longest side of the triangle. That's true no matter what for all of math. The hypotenuse is always the longest side of the triangle. But then we have our adjacent and our opposite. So the way we figure out which one that is the adjacent and the opposite are always going to be the two shorter legs. The adjacent will always be the side that is shared with the angle. So angle A will have the hypotenuse, the other leg will be your adjacent side. Again, adjacent side is always shared with the angle that you're working with. The opposite side is just exactly that. It's opposite of the angle you're working with. So for angle A, right here, the opposite side would be the side that it does not share with the angle. So that would be, in this case, side BC. Now, if we were working with, I'll use blue this time. If we're working with side C, or angle C, we still have our hypotenuse as the longest side. This time, the opposite side would be the side that does not run into angle C. So it's not going to be BC because that's one of the sides of angle C. So our opposite is going to be side AB over there. Then our adjacent is the side that is shared with the angle. So for angle C, BC would be your adjacent. So again, those all just depend on which angle you're working with. We're not going to use the trig functions for the right angle because then your opposite side and your hypotenuse are the same thing. You're only going to be using these trig functions on the side or on the angles that are not the right angle. So that's going to come in handy as we go through our lesson for today, because today working with angles of elevation and angles of depression, it's really just doing what you guys did in those last couple lessons, but instead of just being given a triangle and finding a missing side or angle, it's going to be more real-world applications here. So if I move ahead here, if it'll let me, there we go. So first of all, we're going to talk about what the angles of elevation and angles of depression are. So again, many real-world problems, real-world applications here. Everybody always asks, when am I going to use this in the real world? Here's some examples. So many real-world problems that involve looking up to an object can be described in terms of angle of elevation. So again, angle of elevation, you are looking up at an object. It's being elevated, which is the angle between an observer's line of sight and a horizontal line. When an observer is looking down, instead of the angle of elevation, it's called the angle of depression. And that is the angle between the observer's line of sight and a horizontal line. So, to move on and do some examples with this, I'm going to skip that one and just get into the examples that we'll do together, as they will make more sense here. So, looking at a hilltop, the angle of elevation from point A to the top of a hill is 49 degrees. If point A is 400 feet from the base of the hill, how high is the hill? So we've got our hill right here. We're trying to figure out the height of the hill. We know point A, we could say that point A is where you are standing. You're standing 400 feet from the bottom of the hill, and you're looking up to the top of a hill at a 49-degree angle. And we need to find this missing side right here. So this looks a lot like what you guys did in the last couple lessons. We're given one of the angles, we're given one side, and we need to solve for the opposite side. So in order to do that, we're going to use one of our trigonometric ratios. Now, since we're working with angle A, again, the longest side is always our hypotenuse. The side that angle A is included with is our adjacent, and the one across from angle A is our opposite. So in this one, we're working with opposite and adjacent. If we think back to what we talked about just a few minutes ago, opposite and adjacent is TOA, meaning we're going to use tangent. So we would have the tangent of 49 is equal to the opposite, which we don't know, over the adjacent, which is 400. Then, grab my calculator here. In order to solve this, we need to get the x by itself. So we're going to multiply both sides by 400. Those cancel. So now we're going to do the tangent of 49 times 400. We're going to go, if they don't tell us what to round to, always plan to go to the nearest tenth. So this would tell us that x equals 460.1. Since we're doing a real world problem, we need a label, and it is feet. So using that, we can say that the hill is 460.1 feet tall. So let's go ahead and do another one here. This time, find the angle of elevation of the sun when a 12.5 meter tall telephone pole casts an 18-meter long shadow. So for this one, we're working with this angle right here, which we don't know. We have the adjacent side and we have the opposite side. So again, we're going to be doing the tangent, but this side, this time we don't know the angle, so we're doing the tangent of x is equal to the opposite, which is 12.5, over the adjacent, which is 18. So then what we're going to do, when you're given the tangent of x is equal to 12.5 over 18, we need to figure out what that angle measure is. The same thing as saying the tangent of x is equal to this. We could say x is equal to tangent to the negative first of 12.5 over 18. Now, tangent to the negative first, we can call that the arctangent or the inverse tangent. So then all we have to do is, again, on our calculators, you see on this calculator, I've got my tangent button, and right above it is tangent to the negative first. So I'll go second tangent, and then put 12.5 divided by 18. Oh, it didn't do it all. 12.5 divided by 18, and that gives me x equals 34.77, which will become 34.8. We're solving for an angle measure, so our label would be degrees. So two different problems. One of them, we were given an angle and a side. We found the third side. The second one, we were given the two sides, and we had to find the angle. Again, this looks a lot like what you guys did the last couple lessons on Khan Academy, just putting it into some real-world story problems. Let's do one more of these. So this one, a ski run is 1,000 yards long with a vertical drop of 208 yards. Find the angle of depression from the top of the ski run to the bottom. So for this one, what we're going to do is, again, we're given two of the sides, and we need to find that angle of depression. There's actually two different ways that we can go about solving this one. The first way is, if we look at this, we know that this side is 208 yards, the height is 208 yards, so I can draw that side in over here and say that that is 208, and I'm trying to solve for this angle right here. So I'm going to be using the opposite side and the hypotenuse. Since I have the opposite and the hypotenuse, that would be so we're using our sine. I would say the sine of x is equal to the opposite, which is 208, over the hypotenuse, which is 1,000. Then again, just like last time, this would become x equals the inverse sine of 208 over 1,000. So I'm going to go ahead and plug that into my calculator. And that's going to give me an angle measure of 12 degrees. Now the other way that I could have done this, I'm going to do in blue here, is I could have found this angle right here, which in that case I've got my hypotenuse and my adjacent angle. So adjacent and hypotenuse is going to be cosine. So I would have the cosine of x is equal to the adjacent, 208, over the hypotenuse of 1,000. So I would do my inverse cosine of 208 divided by 1,000, which gives me an angle measure of 78 degrees. Now, since we know that this is a right angle right here, and this part is 78 degrees, then the missing part of that angle that we were trying to solve for would be 90 minus 78, which would give me my answer of 12 degrees. So a couple different ways to solve that problem. We're going to walk through one more problem together, which it's similar to what we were just doing, except has some extra steps added in. So Olivia works in a lighthouse on a cliff. We've got our lighthouse on the cliff right here. She observes two sailboats due east of the lighthouse. The angle of depression to the two boats are 33 degrees and 57 degrees. Find the distance between the sailboats to the nearest foot. So I'm going to draw in some of this information with a color that will be a little bit easier for you guys to see. We've got point D there, point A, and point B. This is point C up here. We've got a height of 85 degrees and a height of 110 degrees, which means our total height is going to be 195 feet. Now, we have to figure out, ultimately, the distance between our two boats, the distance between point A and point B. So in order to do that, we need to come up with some missing information here. We know that the angle of depression right here is 33 degrees. The angle of depression to this line is 57 degrees, which means that between those two is going to be an angle of 57 minus 33, which is 24 degrees. Now, to be able to see this a little bit better, remember these notes are up on Schoology as well, so make sure if you need to, you can go look at that as you're following along with this video. So then we know that this is a 90-degree angle. If this is 57 degrees, 90 minus 57 gives us an angle measure of 33 degrees. So this portion, this angle right here, is going to be 33 degrees. So now that we know all of that information, and then we can say from our vertical line to this line is an angle of 57 degrees. So now that we know all of that information, what we're going to try to do is we're going to come up with the total angle measure, or the total distance from point D to point B. Then we're going to come up with the distance from D to A, and then we can subtract those to come up with our distance from A to B. So I'm going to find the distance between D and B first, from the bottom of the cliff to the furthest boat out. In order to do that, I'm going to draw in a triangle that has just the information that we need. Because in this, there's a lot of different information up here, and we don't need all of it for this part. So the triangle that I need is going to be triangle CDB. So in order to do that, what I'm going to do is I know that the height here is 195. I know that the angle on CDB is 57 degrees, and I'm trying to find this missing side. So working with this angle, I have my opposite and my adjacent, which means I'll be working with the tangent. So I'm going to go ahead and say the tangent of 57 is equal to the opposite, x, over the adjacent, 195. Now I multiply both sides by 195. Those cancel. And I get x equals the tangent of 57 times 195, which is going to give me 300 feet. So I can say this distance is 300. Now I just need to find the distance from A to D and subtract that from 300, and that'll give me my final answer. So in order to do that, again, I'm going to draw a separate triangle using only the information that I need here. So this time I've got angle C, angle D, and angle A. I don't know AD. CD is still 195 feet. And then my angle here is 33 degrees. So using this, again, opposite and adjacent, so I'm going to be using the tangent function. Tangent of 33 is equal to x over 195. Multiply both sides by 195. So tangent of 33 times 195 gives me, this time, I'm rounding to the nearest whole number. It says to the nearest foot in the answer, so that's why I'm rounding to the nearest whole number on these. So this is going to give me x equals 127. So from D to A is 127 feet. So now I know that DB is 300, DA is 127, so I can use subtraction. 300 minus 127, and that is going to give me my length of 173 feet. So again, similar to what we were just doing, just adding in a few steps there, and we were able to find the distance between those two boats just based on a couple different measurements that we were given at the very beginning. So that's the lesson that you guys are going to be doing today. Homework is right here, page 466. Again, this is lesson 8.5 in your book. You're going to do numbers 4 through 18 even, 19 through 21, and 27 through 28. What I actually want you guys to do for this one is I want you to do all of your work and everything on a separate sheet of paper, but then to turn in your answers, what I would like you to do is go ahead and just make a Google Doc that just has your answers on it. It doesn't need to have all of the work, just your answers, and go ahead and again, make that into a Google Doc and just share it with me. That'll be a little bit easier for me to go through and grade. Again, if you have any questions, feel free to reach out to me. I'm happy to email, text, call. If we need to get on Zoom or something like that and go over something, I'm more than happy to do that. And again, just please make sure you're doing your best to be getting this stuff done. Most of you are doing really well with this. There's a few that are struggling, so just make sure that you're getting this done and reaching out if you need anything at all. See you guys later.